virtual chapter meeting. Too bad I don't get to see everybody's face in the at National Instruments, our usual location, but this is still getting there pretty good, and we'll try to make this as fun or as more interesting as we can. This is the OWASP Austin chapter meeting for June 2020. Welcome. Here's the chapter leadership. I'm the top there. I'm the chapter leader over all kind of things. Kate, who you've also heard on here, is kind of our speaker coordinator. We also have Matt Pardo, who I think is on here also. He's our education coordinator. We have Tiana, who's our sponsor, Ryan, who is our PR marketing, Griff, who is our membership coordinator, and our advisory board of David, James, Josh, and Bankham. Josh, who is doing a great job of helping run through the Zoom stuff. If you signed up for this and want some CPEs, yes, AJ, I'll try to get those to you still. Send us an email. We do it only upon request most of the time, and we usually are fairly quick. There's opportunities to support OWASP. OWASP is entirely volunteer, well, not entirely. The chapters are entirely volunteer run, managed, everything of that nature, while we do have an OWASP Foundation, and they provide lots of activities. There's many ways you can support it. You can become a volunteer to help us do things, leadership, and then obviously speaker opportunities like this one with Ali. There's also ways you can do in Smile, Amazon Smile, and remember, if OWASP is a 501c3 organization. And of course, if you really want to go into, which I have to in like 6 days, I have to renew my individual membership. It's $50 for 1 year, 2 years, $95, $500 for a lifetime. There's also corporate memberships starting at $5,000 if your company ever wants to come up on banner pages for OWASP itself. We then start doing that, and there's different levels. And as students, of course, there's a special discounted rate, which I thought was either $20 or $25 or even less, but it really depends on what you contact us on. Griff is our membership coordinator, so you can contact him if you have any questions. There's also an OWASP mailing list in Google Groups. Look us up on austin.owasp.org is where you can find a way to get to that mailing list. It's really quiet, pretty much announcements about this meeting and maybe the happy hour and a few other things like that, but not much. Slack. Somebody asked earlier about Discord. Unfortunately, we're not on Discord, but we do have a Slack channel. OWASP Austin has its own at the URL you see there. I'm not going to even try to read that. OWASP itself, the foundation, has a Slack channel too, which has a easier sign up. We just don't have the money to pay for it. The OWASP Austin, but there is a channel for the chapter inside there too, and I try to post everything when we're talking about chapter announcements. There's discussions and all types of fun stuff in the OWASP Austin Slack that, like the study group, which I'll talk about here in a bit. And there is a LastCon Slack, but I've yet to find actually how to get people onto that one. So we can send you invites, but otherwise that's what has to happen. So send us an email if you want to get into the LastCon one. We are now on Meetup. I think some of you all probably came through Meetup. A lot of people also came through Eventbrite. That's where we've been traditionally at. We just started using Meetup because, well, the foundation is wanting that direction. It's tied to a lot of the other OWASP, and it's good stuff. We have 58 members from when I took the screenshot last week, and we have probably even more. Welcome everybody who came via that route, and hope to see you when we actually get back to in-person meetings. We have a LinkedIn group if anybody's curious. Not a lot of traffic there. We used to get some PR and marketing stuff on there, but it's not bad anymore. But it's some good ways to see other people on the OWASP chapter. YouTube, Vimeo, we have a lot of videos out there. There is a Austin OWASP chapter channel now. It's under the umbrella of the OWASP Foundation, so you can find us there. In Vimeo, you look for the OWASP Austin channel again. The archives up till August 2018 are there. The newer stuff we're trying to move to YouTube because, like I said, it's under the whole umbrella of the OWASP Foundation. Study group is still meeting, but they are doing virtual only. Talk to matt.pardo at owasp.org about the virtual study group. I am not sure exactly what they're working on. It ties on to the next thing a little bit. LastCon. Unfortunately, we have to make a not so happy announcement. In the past month, the LastCon Planning Committee has determined that first, we are not having the in-person conference. And we also did the evaluation for a virtual conference and decided that because one of the core activities besides the AppSec training that we get to give at LastCon is the face-to-face. A virtual conference is not ideal for us anymore. So we're going to postpone LastCon 2020, actually cancel LastCon 2020, and we are looking forward to LastCon 2021, which hopefully by that time we will be able to do some type of face-to-face and be able to get that into focus. Anybody who has purchased a ticket for LastCon 2020, which is very small, less than I think 15 people, we will make a full refund. We're not going to try to carry over or give you free passes or anything. We're just going to refund that money and pass it back. If you have been a submitter to LastCon 2020, we are going to actually reach out to you and talk to you about opportunities, because obviously there's virtual meetings and things like this. And that does change up a little bit of the OWASP Austin meeting group, because we typically don't meet in October because of LastCon. So we may have a chapter meeting this year. But like I said, we're sorry to see, I think all of us are kind of sorry to see that LastCon 2020 is being canceled for the year. If you have any questions, feel free to reach out to me or anything in that. And another thing that was canceled was the Austin Security Professionals Happy Hour, which we try to host at the Brass Tap, but unfortunately with everything, we know it is. There are some other upcoming local events, which apparently I wrote this before June 25th because I put a Austin Hackers Association upcoming. So you can go to the austinissa.org if you want to find some local Austin activities. They have a fairly good calendar. It's kind of getting sparse again, so might have to look around to see if there's anything anybody else is doing new, but they do have AHA on there, ISC Squared, ISSA, ACP, and things like that. Does anybody want to talk about any other meetups or local events that they are trying to attend here in Austin or otherwise that they want to announce? Obviously, we had two kind of regional activities that were, DevOps Days was canceled back in May. Houston SecCon was postponed, I believe, till September, and B-Sides has been moved to December for this year currently. No, I don't see a hand or anything in the people, so it sounds good. Speaking opportunities, as we said, we now will probably have an October meeting, so we probably have a speaking opportunity for the month. We'll reach out to some of the people who submitted LastCon if they want to do it, or find somebody else.
Yeah, they might, Kyle, just one thing, they might want to stick with their original plan to present at a conference, so we won't force any of them, but please reach out. I have an opening, newfound opening for the October chapter meeting, and looking for a great talk.
Like I said, we're not gonna force anybody, but if they wanna reach out in October, then hey, it'd be a great opportunity. Is Allie here yet?
I've pinged her frantically a couple of times. I'm not seeing a response. I've tried from a couple of accounts.
Kyle, I could always throw something up there that I've done in the past too.
Oh, great. That'd be because people made the time to come and made the effort. So I'm seeing no response from her.
All right, let me.
So you want to take a few minutes and get some.
We're about 15 after here, anyways. But I will stop sharing at least so people be aware of that. And
let me pull something out of the hat here.
Josh is one of our great former chapter leaders for OWASP Boston, actually, but he's gone everywhere. Wow, you're no longer at NI, so he's running his own company now, but he does a lot of great things for the AppSec community. He's done some great presentations at wow, how many conferences have you done at now? I mean, you did Black Hat at one point, didn't you?
Yeah, I've done Black Hat, B-Sides Austin, B-Sides Las Vegas. I've done B-Sides in Vancouver, all over the place.
Josh is one of the great resources we have for Austin, and he was a foundation board member for OWASP itself, and he's just great for having in this community.
Let's do this one. So this is actually the talk that I gave at B-Sides Vancouver back last year. It's probably one of the more up-to-date talks that I have right here. So let's go ahead and share my screen.
Thank you so much, Josh. You know what I might suggest, just one thing real quick, is we could move Allie to October if you guys think
That's a
so. 'Cause
possibility too.
I think it's an honest mistake. She didn't stand us up. She was like, "What?" So,
Yeah.
okay. Thank you so much, Josh.
Yeah,
Really
no
appreciate
problem.
you jumping in.
No problem. Let me share this out. There we go. All right. Hopefully you all can see my screen. I wasn't prepared to give this talk, but I have given this talk in the past. So hopefully we can kind of make our way through it. The talk is about architecting for security in the cloud. And Kyle kind of mentioned a little bit about me. I'm Josh. I'm a former OWASP Foundation Global Board member. I'm the creator of Simple Risk, which is a free and open source risk management platform, and formerly the information security programmer at National Instruments. I ran the security team there for about a decade before I moved on to do Simple Risk stuff full time. So this talk kind of stems from a lot of the research that I've done on the Simple Risk platform. I've looked a lot at how do I properly architect something in the cloud, and we use cloud in quotes because it really just, the cloud is different depending on who you are. If you're the customer, it's a synonym for software as a service, right? It's something I pay somebody money and then they provide me this service based on that. If you're the hosting provider, then that usually means somebody else's data center, and we're basically putting our stuff in somebody else's hosting environment and calling that the cloud. The challenge here was that Simplest, the software that I wrote, was initially built as an on-premise internal use application at National Instruments. And I open sourced it back in March of 2013. I gave a talk at the B-Sides Austin conference where I talk a little bit about the struggles that I had with risk management. And you know, long story short, the place where I really struggled was in the tool set. I was trying to figure out, I tried to use Excel spreadsheets for a while. That didn't scale. Tried to use a Lotus Notes database to manage risk. That wasn't dynamic enough. Looked at the big GRC tools. I realized that those big GRC tools were just too bloated and complicated. And when I put a $500,000 quote on my VP's desk, she laughed at me. She said, your budget is $0. Go figure it out. And so, kind of stuck between a rock and a hard place, I created this Simplest tool. I ended up open sourcing it at the B-Sides Austin conference. And so I never really intended this to be a software as a service thing. I never really intended it to be a cloud thing. And the business of Simplest came about because all these other users said, hey, I really like this tool, but I don't want to host it myself. I don't want it to be in my environment for whatever reason. Maybe it's their environment doesn't support, Apache and PHP and MySQL, or maybe it's they wanted to focus on risk management and not have to deal with all the intricacies of having a server and backups and monitoring and all that stuff. So for us, the cloud was really leveraged for agility. We wanted to be as agile as possible. And because the data that was being hosted by us is risk data, it's important data about the vulnerabilities and risks that organizations have, security was obviously a huge concern. So to give you a little bit background on the Simplest architecture, I mentioned this earlier, but it's some sort of a web server. We use Apache. You can use Nginx or IIS as long as it supports PHP. So all the code is written in PHP. And it uses MySQL database as the backend for all the data storage pieces. I know what you're thinking, and I'm going to cut this off at the knees right now. So PHP is not a vulnerable language. People who write in PHP write vulnerabilities. And so back in 2014, White Hat did a pretty interesting study, and they looked at the average number of vulnerabilities across all the different languages. And that included, .NET, Java, ASP, Cold Fusion, Perl, kind of all the big things that were at the time there. And obviously, other languages have kind of surfaced since then. But these were kind of the big ones back then. And if you look at PHP was basically in the same boat as everything else. So really what this tells us is that it has nothing to do with the language itself. It has to do with the people who are writing it. And if you've ever done, I did a OWASP Top 10 training at LastCon for the past 4, 5, 6 years, something like that. If you've ever been to my training, then you know that this is all about the vulnerabilities, and people design vulnerabilities. The code can be modified to make it secure or insecure. White Hat basically said, at present time, we can say that all of these aforementioned items, language, industry, organizational size, development processes, don't matter much. And if they do, it's only slightly and under very specific conditions. So why did I use PHP? The first thing was I wanted the same code to work across all these different platforms. And today we support Red Hat Linux, CentOS, Oracle Unbreakable Linux, Ubuntu is where we do most of our development on. We've got Windows servers, and basically any platform that you can think of, we're pretty much supporting based on being able to use PHP. The second one is installation is super simple. You can do basically like a single command to install a LAMP stack. So that's pretty easy. And then there's lots of documentation for when things aren't simple. If you go and you search on the internet for, PHP something broken, you get like 1,000 articles talking about why that is and here's how to fix it.
Hey, Josh.
Yeah.
There was somebody asking on the previous slide, it says, what do you mean by mean number of vulnerabilities?
So you probably have to go into the white hat report, but mean typically means that they take the number of vulnerabilities across all of the applications, they sum them up, and then they divide it by the total number of vulnerabilities. So if you're familiar with statistics, there's basically 3 ways to do average. There's mean, median, and mode, and mean basically means sum them all up and then divide them by the total. So yeah, thanks for that, Kyle. So the last one is I knew PHP really better than any other language. I actually started kind of working on Simple Risk in Ruby, quickly realized that my strength was not Ruby. I didn't want to learn a new language for this thing that I was writing to do some stuff at NI. And so I went with PHP because it's what I knew. In terms of coding best practices, so anytime you're writing an application, there's some kind of generic things that you can do. And we cover a lot of this in the training that I've done at LastCon. But the first one is input validation, which basically means looking at all the stuff that's coming into your application, all the sources of data that's going into your application, and validating that that is what you want it to be. So, if I'm taking in, I don't know, a value that's a integer representation for a risk category, I want to make sure that the thing that gets input is an integer. Because on the client side, they have control over those forms, and they could submit into the application something that's not an integer, and we want to make sure that we're processing that appropriately. Output encoding is typically something that you do for prevention of things like cross-site scripting. So it basically means that if somebody puts data into the database that has HTML characters in it, when that gets displayed back onto the page, we want to make sure that that's not displayed as HTML characters. So, otherwise they could basically put like script tags and things like that. So when it gets echoed back into the page content, now we have a cross-site scripting vulnerability. So we do what's called output encoding. We basically take like a less than character and we turn it into ampersand LT semicolon. Hashing and salting data for data that's used only for comparison. So think passwords is a great example here. So if you have a password, I don't need to store your actual password in my database. If I store the actual password in my database, that's a security vulnerability in and of itself, because if my database gets compromised, all my passwords get compromised as well. And so what we want to do is we want to hash that password. Even better, we want to hash it with a unique salt for that user, and then store that value. So we don't actually store the password, we store the password hash. And then when somebody goes and logs into the application, we simply hash their password with the salt that we've stored, and we compare the hashes. So we don't ever have to store that sensitive data that's their password. Using industry standard crypto algorithms, anytime you start to write your own crypto algorithms, it's a recipe for disaster. And so OWASP guidance has always been use the industry standards. If your language that you're writing in has some sort of language or some sort of standards around crypto, use those. Don't try and roll your own. And then the last one is authentication and authorization checking. We want to make sure that the users who are accessing our application are the users we intend to access our application. And then out of all those we intend to access it, we want to make sure that they're doing the right thing. So I don't want everybody to be able to review a risk. I only want the people who I assign as risk reviewers to be able to review my risk. And so we have to follow that. In terms of the architecture, so the idea here was that we would start with kind of a clean slate. And I realized this is a luxury that I had that not everybody else has. But in my case, I would basically said, all right, well, I'm starting from scratch. with this application called Simple Risk, and I want to basically take this thing and turn it into something that's a SaaS platform. And so start with that kind of green field, clean slate, and I have a secure web application. And I can call it a secure web application because I've done all those things that were on the previous slide. So here's our application. Now, how do we keep that application updated? That's the first thing that pops into my head. And the answer to that is keep it in a private GitHub repo. And in order to make sure that nobody else is modifying the application, changing the code, things like that, I have access control over who can push out changes, right? There's only a few people who are developers. I don't need my sales guy or my marketing guy or whatever to be pushing out changes to the code. That would be dumb. So we want to control who can push out changes. We want auditability of who makes changes. So I want to be able to see if somebody changes the application, I want to see who did that. And then probably more importantly, I want to see what those changes were. So by using a GitHub repo, we can see anytime somebody checks in code, we can see who made the change, what change was made, and when that change was made. And even better, we can roll back if changes break things. You can basically just go and say, I want to roll back that particular change and get automatically updates. You commit the new rollback and you're back where things were. So it's very, very simple to do that. The second piece is around automation. And so, if you can create a repeatable thing, a repeatable process where your tools are going to automatically look for things, do things, make things happen, it means that there's a lot less manual stuff that's involved. And as we all know, it's people that create issues. Even in the case of automation, it's a person who wrote the automation who's creating the problem. So when we use these automation tools like Chef as an example, Puppet, Salt, there's a whole bunch of them, the servers know when new code is made available. And that code automatically gets rolled out to the servers, and we minimize deployment mistakes because we're using this automation path. We want to ensure that our server configuration is consistent across all of the different servers, across every environment. And we also want to have different dev, test, and production environments. So best practice is we don't just roll all of our stuff to production right away. We want to make sure that we're doing some QA work. We're checking to make sure that everything is in a good state when we do that. It looks like somebody had a question here. No, maybe. Is it common for you to find companies not using version control? So I am not I don't go out and do pen testing. I don't do risk assessments for other companies. I write software that does risk assessment. So I don't have a really good handle on whether it's common or not common. What I tend to see is that a lot of companies are using version control, but they may not be using it across every application in the right way. And then certainly not all of them are using version control for automated deployment. So I think that's probably the one big difference that I've witnessed there.
Yeah, you see a lot of the version control stuff is actually application-wise. Most companies are fairly good about it, but when you start going into the CI/CD pipeline, some of those things aren't version controlled real well.
Yeah, that's a great point. And so, when I was writing the simplest infrastructure, we write it as infrastructure as code is what you hear it referred to as. So you're actually creating code that creates the systems, that creates the deployment. For example, when I spin up a new customer in our AWS environment, I've written a whole cloud formation script. And that cloud formation script defines, here's all the servers I spin up, here's the connectivity, here's the firewall rules, so that every single one is a repeatable thing. I don't have to worry about, oh, I did that one differently than that one. Every one builds in the exact same way. And then the other cool thing is you can actually do auditing against that cloud formation script, and you can say, what has changed? What's the drift, so to speak, between what I rolled and what it looks like today? In terms of architecture, so now we have our GitHub repo. That's where all of our configurations and our application can be stored. We have our web application server. That's where our web application is being hosted. And now we've introduced the idea of having some sort of an orchestration server, something that's actually going to run and say, hey, I need to pull some stuff out of GitHub and I need to push it to this thing, or I need to check to make sure that this has the latest code on it, that kind of thing. So because we've introduced more servers, we have to look at how do we harden our servers. And so the first thing is ensure that routine patching of operating system and application is happening. This is one of the biggest ways that vulnerabilities can be introduced, is if you're not doing your patching. And we all know this. We've seen tons of worms and other types of exploits over the last few years where entire organizations have been compromised because they didn't do proper patching. So we want to make sure that we have some sort of a process for doing that. The really cool thing is a lot of cloud platforms now have things like that baked into them. So I think in Amazon, they have something called Amazon Inspector, where they can basically look at, and they can look at what patches you're missing. They can automatically deploy patches for you, all sorts of cool stuff. So when we start looking at these hosted platforms like AWS, Google Cloud, Azure, and whatnot, we can look at some of those things. The second one is turning off unnecessary services. A lot of people don't realize there's a lot of services that are running when you install a default OS, and not all of those are needed. Many years ago, it was, hey, we started up and it's automatically running Telnet and Cups Daemon and weird stuff like that, where you're not going to use that unless you're running a printer server, and you're not going to use that because SSH is better. So understand what kind of things are on your operating system, what things are necessary for your application to run, and then turn all the other crap off. You don't need it. The next one is enabling a host-based firewall with default deny rules. So this is something that kind of speaks to defense in depth, which if you're not familiar with it, it actually comes from the military term. It basically means we don't rely on a single control. We actually like to look at having multiple controls in place. So if one of those controls fails us, we have a fallback. We have something else that we can look at to make sure that our data isn't compromised, our application doesn't fail, and so on. And so even though AWS provides me with what they call security groups, which are default deny rules at the network layer, I also want to do this on my hosts. And so I use Uncomplicated Firewall, UFW, on my hosts, and I set up default deny policies. And I say the only thing that's allowed in is SSH from this Bastion host and HTTPS from the load balancer. And at that point, I've kind of locked this down so that there really isn't much things that can get to this system. The only thing that we have to worry about at that point is, what's going out. And even the outbound stuff we can restrict mostly to things like, hey, I need HTTPS updates coming from the Ubuntu update server, and I need to be able to speak to that database over there. So we can really lock things down. And that way, if UFW fails or gets turned off, or security groups get updated because somebody's doing debugging, we haven't just opened our application up. One of the biggest issues that we found at NI was somebody did some debugging at one point on the firewall rules, forgot to, they turned them off when they did the debugging, forgot to turn them back on when they were done with the debugging, and that resulted in somebody accessing a host that they shouldn't have. So, those kind of things are incredibly important for us to understand and handle in that way. And then the last one there is administrative access only allowed from Bastion hosts. So what I like to do is I basically say, this is my host. This particular server can access these other servers, but then I can focus all my attention on locking that guy down. So if I'm going to SSH into my environment, I SSH through that host, which is locked down. I'm the only person who has access to it. And now nothing else can SSH to those unless they figure out a way to compromise that host that I've poured a lot of time and energy into locking down. AWS has gone a step further in this process too, and they now have a service around SSH where you basically have to have a key and you have to go through a certain process to SSH through Amazon in order to access those hosts too. I forget what it's called, but they have a function that provides basically the same kind of Bastion host, but through their capacity. And it uses IAM rules to do it. So our architecture has grown a little bit. We now have a Bastion host in place that provides our SSH access to the web application server as well as the orchestration server. So now let's talk about the database. I mentioned Simplest runs on MySQL. So we have to secure that database somehow. And the first bit is native database security. We want to use long and random passwords for database users. Password management is kind of a crucial thing all over the place, but it is important in databases as well. So we generate a secure, long, or random password, uppercase, lowercase, numerics. Sometimes databases have issues with special characters. Just be aware of that. For example, single quotes in passwords is probably not a good idea. That could potentially break applications that you're using those passwords with. The next one is least privilege for database user permissions. So this was something that I was super careful about from the very beginning. You don't want to give your users every single permission. You know, there's things that are basic permissions, like being able to select data from the database, update database data in the database, delete data from the database. Those are kind of basic things. But then you get to some more interesting permissions, like being able to alter table structure. So if I want to be able to add new columns, do I want to be able to drop tables, things like that? That might not be something that you want every user to be able to run on that. And so you kind of have to understand, these are the things that I need to do with my application versus these are the permissions that I need in order to do it. And basically adopting a least privilege approach says that those things I don't need to do, we're not going to do. And then the next one here is restricting host for the user to only application servers. And so in MySQL, you can basically say, this is the database user. This database user has access to these databases. And you can even go a step further and say, the host that this user is connecting from is this IP range. And so when we look at our architecture there, we can basically say, the only thing that should be talking directly to the databases is my web application servers. And so I want to go ahead and I want to restrict the host only to the IPs from those web application servers. In terms of AWS, there's a couple things that we can do. You can leverage security groups with databases as well. So just like we restricted host with the database user, we can create a security group and we can say only the application servers can talk to this. So we're narrowing that attack surface. This whole talk is all about how do we narrow that attack surface so that somebody trying to compromise our application, they're going to be stifled kind of at every single turn. And then the other very, very big one is make your database not publicly accessible. So you have options when you spin up a new RDS server in AWS and in other environments as well. Do I want to make this database public? Do I want to give it a public IP address? And you should say no, absolutely not. In fact, my recommendation, and I don't think I have this in this talk because I did it later on, but my recommendation is to basically split your structure out into 3 networks. Create 3 subnets in your VPC, one for public, and the only thing that should be seen in that public subnet is your load balancer. Create one for private, and that should be your application servers, and the only things talking to that is your load balancer. And then create another subnet, which is your sensitive subnet, and that's where your database should live. So your application servers talk to the database server. You have very specific security groups that give those access. Your load balancer talks to your EC2 servers, your Elastic Cloud compute servers, and you have specific security groups allowing that. And the only thing that's accessible outside is your load balancer. So you've restricted the protocols that an attacker can attack to HTTPS, and that's it. So now our architecture has grown a little bit. We now have our application server talking to our RDS or MySQL database as well. So let's talk attack surface. I just kind of mentioned that in passing a second ago, but let's talk about what that actually means. So attack surface of a software environment is the sum of the different points or attack vectors where an unauthorized user, i.e. the attacker, can try to enter data or extract data from an environment. So I have a picture here of a castle, right? But if you look at that castle, it has no moat, no boiling oil towers, no catapults. There's nothing really protecting this castle. It's just, people would probably describe it more as like a house in the country, right? That looks like a castle. And that's because there isn't any of those things. So if you were going to attack this particular castle, you could probably devise 100 different ways to do it. I'm going to go down the chimney. I'm going to parachute into there. I'm going to break a window. I'm going to kick open the door, right? There's so many different ways that we could attack this structure. But our goal really should be to minimize that attack surface. So if we took that same house and built a moat around it, then we've minimized the attack surface, right? Because now I can't just go up and break a window. I have to get a boat and I have to cross this moat. And if we fill that moat with alligators and sharks with laser beams, man, I don't think somebody's going to try and cross that water, right? So, now it's just the parachuting into the castle that we have to worry about. Or, somebody who creates a boat that's, impervious to sharks with laser beams. So we've minimized the attack surface. We're trying to make it so that the number of ways that somebody could possibly attack our application is as few as possible. So our current attack surface looks something like this. And I've tried to carve it out a little bit more so that you can see. We have something called a virtual private cloud. It's a VPC in the AWS environment. And the whole idea is that this is a dedicated environment and things within the VPC talk to each other, and the VPC doesn't really talk with other things. And so by creating everything in this virtual private cloud, we can do actual isolation between different customers, different servers, different instances using this VPC concept. And so our RDS database, the Bastion host, the orchestration server, the web application server, and our application all live inside that VPC. And for now, we can kind of think that as a closed box. Unless if you can get into that VPC, there's no way that you can attach to any of those things, which really means that there's two attack surfaces in this VPC. There's the Amazon console, because using the console, I can connect directly to any of those hosts, but I can secure that. I can create IAM user accounts and do things to secure my console. And then the GitHub, because our application server is pulling data from GitHub via HTTPS. If somebody compromises my GitHub repo, then they've basically compromised my data there. Let's see, we've got a chat here. So the cloud and all of the routing rules tend to eliminate the need to create proxy servers. I don't know if I'd say it eliminates the need to create proxy servers. So I have some instances where I actually run an Nginx proxy that is sitting in a one of those kind of public nets. And then I have the application server that it's proxying on behalf of that's sitting inside of that private net that I mentioned. So EC2 server, or I'm sorry, an Elastic Load Balancer, that load balancer that I mentioned, is just another form of a proxy. It's a web application proxy. It serves 443 as the proxy port. In my Nginx case, that does basically the same thing. I've just used a single server to spread the load out across a lot of other servers. So it doesn't necessarily alleviate the need for a proxy server. It just changes the architecture of where that proxy server goes, so that proxy server is the only public representation of your data. And then we have Castle Lava. I guess what Britton is saying is that we should use Lava in our moat, and that might work better. So is the database still on the web application server? No. The whole goal of this is to break the database out. Best practice says that you should have different applications, different types of servers split into separate servers. And there's a number of different reasons for that. But probably the most obvious is by putting it on separate things, you're able to upgrade one component without necessarily impacting the other component. So database server is separate. In Amazon, they call that an RDS, a relational database service. So that's on a RDS. And our web application server is sitting on an EC2, Elastic Compute Cloud instance. So they are completely separate things. One of the cool things about RDS, and I don't think this is in the talk, is you have the concept of multiple availability zones. So you're actually running multiple RDS database instances in multiple data centers in the same region, but they're completely separate, physically isolated data centers that we've basically created high availability. So if one of those sites gets nuked with a missile, there's still another site there. Your stuff is still up and running. Yeah, so you've made setups in AWS that had separated out. Absolutely. I would absolutely separate out the database from the application server. So yes, you're on the right path there. All right, so next steps. We need to enable access for customers. So somebody once said that the most secure server in the world is a server that's sealed up in concrete and then dropped at the bottom of the ocean. But that's not usable, right? We need an application that people are actually going to be able to interact with. And then we also need to enable some access for administrators. Somebody has to be able to maintain this application. So how do we do that? So in order to do this, we need to basically enable some connectivity. And so I've got that kind of red area on the left. That's for that's the attack surface, right? That's the things an attacker has access to be able to attack. And then the other stuff is the stuff within our VPC. So what you'll notice is we just add the remote user or the internet. We have some connectivity that we have to provide so that people can do things. And the way that we do this is we basically give access for HTTP or HTTPS to the load balancer. And as I mentioned, we have that load balancer sitting in a public subnet, which is separate from our private subnet where the web application server sits. And this talk kind of predates some of the stuff that I did around that. Sorry, I wasn't planning on speaking today, but hopefully you get kind of the idea of the load balancer really being the only interface that is publicly accessible here. The other piece that we have access to is the Bastion host. We have to give somebody some level of access to that server so that they can talk to the other servers. So we have to allow SSH. Again, SSH is secure shell. It's encrypted communication, so somebody shouldn't be able to break that. Really, the big attack surface here is vulnerabilities in the SSH protocol itself, or somebody guessing, brute forcing passwords and usernames and things like that. So one of the things that we can do to kind of help with that is we can use something like multi-factor authentication with our SSH to beef it up even further, obviously control accounts and things like that. So as I mentioned, attack vectors, we have insider access. So if one of the people who I hire to work on Simpress instances, if they have access and they're compromised and they compromise the confidentiality, integrity, or availability of our application, man, that sucks, right? If the attacker compromises Amazon and they change configurations for the environment, that's gonna suck. If they compromise GitHub and they push malicious code to the environment, that's gonna suck. If an attacker finds a vulnerability in the application and gains access to the environment that way, that would obviously suck. And then if they find a way to access the Bastion host. But we've basically narrowed our attack surface to these very well-defined things that we can plan mitigations for. We can figure out how to address each of these things. So how do we do that? The first thing is the insider threat. Probably number one is background checks. Know who you're dealing with. And if we have those insiders, we want to make sure that they are approved people, that they don't have a history of any fraud, that they don't have any sort of debt or things like that that would make them make some poor choices. And then obviously limiting those who have access. I don't want, I mentioned my sales guy, I don't want my sales guy to be the guy who has access to this environment. It makes no sense. And when I'm talking to a customer and they say, why does your sales guy have access to this environment? I'll go, I don't know. All right, we've got a new chat thing here. Using AWS as an example, can you enforce the use of the admin type user to have an evergreen browser regarding the HTTPS vulnerability? So I haven't seen anything like that in AWS. That doesn't necessarily mean that it doesn't exist. AWS, when you go and you look at the list of services that they offer, it's enormous. There's probably over 100 different things that like you can pick and choose from. So it's possible that that exists. With the identification and access management, some of that stuff, you can enforce the use of keys. You can enforce usernames and passwords. You can enforce password complexity. There's all sorts of things that you can put into there. But I haven't seen anything with respect to the browser and saying you have to use this specific browser that you've already authenticated with in order to access that. I'm assuming that's what you're talking about. What you can do here regarding HTTP and HTTPS is you can restrict, using security groups, you can restrict who can communicate with that. And so if I want to lock it down even further and say, I know that anybody from this particular company who's accessing this environment, their external IP range is X, then I can say only X can talk to my server, my load balancer. And now I've restricted that attack surface even more so that only X can talk to that. All right, so Amazon. AWS Web Services, this is where all that kind of control pieces go. I can spin servers up, I can take servers down, I can run backups, I can look at database stuff. This all comes through Amazon. And so the first thing here is limiting who has access. In our AWS environment, I am literally the only person who has access. I don't want anybody else to touch this. I don't want them to mess with this. There are other ways for them to administer the systems that don't require them with this level of access. If you do have to give them access, and obviously mine may be a corner case, but some sort of role-based functional authorization. So you say, this person has the ability to turn servers on and off. This person has the ability to look at billing information. This person has the ability to back up and restore databases or whatever. So you can create these roles within AWS very, very fine-grained and say these users have these level of permissions. Obviously, long and random passwords is a huge requirement for here, and then requiring multi-factor authentication. AWS ties in with a ton of different multi-factor options, so you can use things like Duo for multi-factor. You can use things like Google Authenticator. You can use physical keys and all sorts of stuff like that. Let's see. Can you cut out SSH access entirely? Yes, you absolutely can. So I mentioned earlier that AWS has a feature that allows you to connect to the server. I forget what it's called though. It's SSH something, but it's basically a feature that allows you to use you access it through AWS. So you're basically saying AWS is speaking directly to the instances. There is no SSH per se on the instances. And if you want to communicate with the instances, you have to go through this SSH capability through AWS. I don't use it. The reality is it adds that, adds a layer of abstraction through Amazon, where you're using like identity and access management that's built into AWS and things like that. So that in and of itself is kind of positive, but I like the SSH approach, and so that's just kind of why I've gone that way. And you can use VPNs and things like that to further restrict that level of access. All right, let's see here. GitHub. So we mentioned GitHub is where our code is stored. We have infrastructure as code that's stored there too. So we can limit who has access, and we can limit who has access even on a per repository basis. So maybe my developers have access to my code. My system administrators have access to the, or I should say developers have access to the application code. System admins have access to the operating system infrastructure code piece. And they don't need to meet. The sysadmins don't need to manage that thing. Obviously, long and random password requirements and requiring multi-factor authentication here is key so that some stranger doesn't break into there. And then auditing. We want to see what's going on. There's a great GitHub UI that you can use, and you can actually see here's all the changes that have been made. Here's the actual changes in the code. So it's really easy to audit it and look at and see, has anything changed that shouldn't have changed? And then our web application, I'm going to point mostly at OWASP. OWASP has great resources around application security. This is the 2013 new, which is really, really old at this point. I think they just came out with a new top 10 last year. But the OWASP top 10 is a great list of top risks. It is not a complete list by any means, but it's a good place to start. HTTPS by default is an excellent place to go because HTTPS provides us with transport layer security. So any HTTP, you can enable the port, but just redirect it to HTTPS. That's all that's needed. I talked at our crypto party in January, and I talked about secure HTTPS configurations. I went through and basically did a whole lot of testing on this, and I came up with, here's the ciphers that you need to enable, here's all the things that you need to turn on, the bits you need to flip in order to have an A grade or an A+ grade with SSL Labs. And so we strive for that kind of thing. Reference that talk if you're interested in that. IPS and web application firewall, obviously you can put these in front of your application to monitor and make sure that there aren't any weird things happening. Somebody trying to attempt to buffer overflow, or cross-site scripting being injected, or SQL injection, things like that. In terms of remote access, so this kind of goes back to what Britton was asking. We want long and random passwords for our SSH users. That's going to prevent the brute forcing. Multi-factor authentication for our SSH user, again, preventing that brute forcing. Let's see, we have a chat. Which IPS do you use? So I've used a bunch of them in the past. I've used things like McAfee. In the cloud, it's a little bit different. We actually use GuardDuty, which is Amazon's kind of built-in tool for all things security. So all your logs feed into it. There's a whole bunch of stuff that basically feeds into GuardDuty, and then it uses that to analyze and say, hey, we're seeing port scanning on this thing or whatever. So I like GuardDuty. It does a pretty good job. There is a cost associated with it, but there's cost associated with all this stuff. But there's lots of different options out there. You can even go and buy, all the companies that you think of, they're like standard firewall companies like a Cisco or a Checkpoint or Juniper or whatever. Most of them have virtual appliances that you can install in your AWS cloud as well. So also for remote access, using key-based authentication for your SSH user, don't just use the password. If you have a key, so passwords are oftentimes broken up into something you know, something you are, and something you have. If you use key-based IP or key-based authentication, that's something you have. Combine that with the password, that's something you know, and that provides for two-factor authentication. Restrict what IP ranges are allowed to talk to our Bastion host. So if I know that when I talk to these hosts, I'm always coming from this IP, that's my home IP, that never changes, I can restrict it down to just that, and then nobody else can access that. And then the other thing is we can disable SSH because we can force you to VPN into the VPC. We can say, hey, you don't even get access to SSH unless if you VPN'd into this environment, and then you can SSH to that server. And that kind of cuts it off at the knees there. Recommendations here. First, determine what is or is not in scope. There's going to be things that you have control over. There's going to be things that you can't control. Try and figure out what are the things that you can control. Second one is create a data flow diagram. Understand how data is flowing within your application, because that's going to help you to figure out how do I protect that application. Third, identify the attack surface. Look at out of the things that are coming into your application, what are the things that some third party has control over? Is it Amazon? Is it a user? What are those things? Because those are the things that are the attack surface. And then the attack vectors or the threat vectors. How are those things coming in? Is it HTTPS? Is it SSH? Is it from that system or all systems? Those are the kind of things that we want to understand. And then lastly here, plan mitigations to reduce the risk of threats. This isn't something where we just go and we say, yes, these attack vectors are open and check the box, we accept those risks and move on. We want to make sure that we're mitigating those risks. So, you asked like, what IPS do you use? Well, if I am using an IPS and it's not being effective, then I should probably reevaluate that and use a different IPS because that might provide more effectiveness or whatever. So with that, I think that's the end of the talk. Hopefully you guys got something out of this. It was, as you know, last minute. But if you guys have any questions, I'm happy to answer them. I guess we have like 2 minutes left.
Free. If you have direct questions, or you can put it in chat and I'll try to relay it.
Hey there, Josh. I really enjoyed that talk. It was like a story. You could stay with it. I think practically any level would enjoy that talk.
Yeah, that obviously was the goal.
Yep. Very good.
So fast, Josh. It was great. It was a great talk. I do not see any questions in the chat or anybody raising their hand in the.
Oh, we have a couple. Let's see. Do you have a link to that January talk you referenced? So all the talks are usually posted into the Vimeo channel. I can see if I can grab that, or Kyle, if you want to dig it up real quick, we can post that. But if you search in Vimeo for like OWASP Austin, OWASP Austin has the longest archive of videos of any OWASP chapter. We've been doing this since 2012, 2010, something like that. We've got probably 8+ years of history of chapter meetings that's in that archive. And so there's lots of good information there. Some of it's older, some of it's newer, but there's lots of stuff in there. And so the January one, I'm pretty sure we put up into the Vimeo archive.
It's not on Vimeo, it's on YouTube.
YouTube now?
Yeah, we're going under the foundation umbrella, and it gets more hits, but it is what it is there, and it's we're not moving anything from Vimeo. We have a lot of stuff in Vimeo, and it's a lot of really good stuff. Some of it's legacy, but a lot of it is really good stuff. And it's everything since August last year or August 2018. I'm not sure. I said in the intro slide, but it should be out there on YouTube now.
Okay.
Hey, Kyle, are we talking chapter meetings?
Yes.
Yeah, because on the OWASP, the austin.owas.org, we have a past events page, and there it's actually a Zoom link.
I believe I changed that actually, but I'll check.
Okay, it's going to Zoom, so you might want to double check that before we
Go to YouTube.
publish that as where the video's at.
Yeah, that's fine. Shouldn't be in Zoom anymore. I believe I've transferred everything over.
Cool. Well, thank you everybody for attending today. If it's your first OWASP Austin meeting, welcome. Hopefully we'll have an in-person one soon, and I get to shake all your hands and not give you coronavirus. So thanks everybody.
Now 1 o'clock. So thanks y'all for attending, and hopefully we'll hear from you next month and have the great presenter.
Yeah, we got a couple of thank yous come in. I've seen 3 go by.